Hello everyone, this is Adam. We all finished AP Physics 2 test, but we still need to review some formulas, because the formulas is the biggest issue for the AP test. Okay, let's start. Start with the electricity and the magnetism. First, the equation for charge is quantized. Q equals to N times E. E is the charge for the electron, and N is the number. Q could be positive or negative, because the N can be positive or negative. Second, Coulomb's law. It means the force between two charges. Force equals to Q times Q1 times Q2 over D squared. Q is the charge for two particles. K is the constant, and D is the distance between two charges. Electric potential energy for two-point charge. It is based on the Coulomb's law. So the potential energy equals to Q times Q, K times Q times Q0 and times 1 over R. So, and rewrite it is 1 over 4 pi lambda 0 Q1 Q0 over R. R is the distance between the two charges. And lambda 0 is a constant. Number 4, relation between electric field and electric potential in charged parallel plate. So delta V, because I use the word delta because I kind of make a triangle. So delta V equals to E times D. V is the potential, E is the electric field, D is the distance. Because between the two parallel plates, the electric field cannot change. So the distance is increasing, the potential is increasing. It's the linear proportion relationship. Electric potential energy transformed to kinetic energy in a uniform electric field. We all know the energy is conserved. So sometimes potential energy can transfer to kinetic energy, and the equation is potential energy equals to Q times delta V. Q is the charge, and V is the changing in potential. Electric force acts on the charge in an electric field. So when the charge is in the electric field, which is uniform, so we can use the formula F equals to Q times E. Q is the charge, E is the electric field, the magnitude, and the force is just a force. Number 7, magnetic force acts on a moving charge in a B field. B is the magnetism field. So we can use the formula, which is really popular in AP Physics 2 test. So we always use that. Force equals to QV times B. Q is the charge, V is the velocity of the particle, and B is the magnitude of the magnetic field. Number 8, magnetic force acts on a current in a B field. So when a current, like a circuit, a straight line, like a current moving in the magnetic field, we always use this formula, not number 7, the point charge. This is the current. So we need to use force equals to I times L times B. So I is the current. How big is like amperes, 2 amperes, 3 amperes, and L is the length, and B is the the magnetic field. Number 9, electric field due to a point charge. So we always use electric field equals to force over like divided by Q. So rewrite it, it becomes to electric field equals to K times Q over R squared. R is the distance, I mean the circular outside the charge. So that's the radius actually. That is for the point charge. Electric potential due to a point charge. It's kind of similar to the electric field because the electric field is over R squared, but this is no R squared, just divided by R. If you know calculus, just a derivative one time, not two times, because the electric field you need to derive two times. So the potential is a little higher level, is integral of the electric field. So V equals to Q times Q, K times Q over R. R is the radius. Number 11. The definition of electric current. This is pretty easy, but some students just forget this definition because current is equal to what? It's Q over T. It means 1 second how many charges pass this area. So the charge per second is equal to current. So sometimes they will ask the unit of the current. You need to say, oh, this is this coulombs per second. Number 12, electric resistance R in terms of length and area. So sometimes we should know the magnitude of the resistance. The resistance is depending on the material, the length, and the cross-section area. Here's the formula. R equals to rho L over A. Rho is the material, is like a constant for different materials. And L is the length. And area is A is the cross-section area. So length is longer, the resistance becomes bigger. If the area becomes longer, become bigger, the resistance is just smaller. Ohm's law, number 13. This is pretty easy because I equals to V over R. We don't need to talk more about it, so we all know that. The relationship between the terminal voltage and the EMF of a battery. So sometimes the battery has the resistance, but we don't know it. But how can we calculate the terminal voltage? So V terminal equals to EM minus IR. R is the small resistance in the battery, and the I is the current in the series. Number 15, the definition of the capacitance. The formula is C equals to Q over V. So it's the charge per potential. Divided by voltage. Number 16, the electric potential energy stored in capacitors. The potential energy is the formula equals to 1/2 CV squared. C is the capacitance and V is the voltage between the parallel plate of the capacitance. Capacitance for the parallel two-plate system with dielectric K. Sometimes we will ask to find the magnitude of the capacitance. Then we use this formula. C equals to K A over D. A is the area of the two plates, and D is the distance between two plates, and K is the dielectric constant. Sometimes you put water or air or glass between the two plates, the K will be different. Equivalent capacitance for the parallel or series capacitors. For the parallel, the total the terminal capacitance equals to C1 plus C2, and series is 1 over C equals to 1 over C1 plus 1 over C2. It's kind of like the resistance, but it totally switched the order. Just it's different. Number 19, so we just mentioned that equivalent resistance for the parallel or series resistance is totally different for with the capacitance. For the parallel, 1 over R equals to 1 over R1 plus 1 over R2. And the series one is R equals to R1 plus R2. Definition of the power. Power is what? Is 1 second. How many work did you do? So the formula is power equals to work divided by time. Sometimes they will ask, what's the unit? The unit is joules per second. Number 21, electric power. This is based on the Ohm's law. Power equals to I square R and equals to V square over R and equals to VI. It's kind of easy. It's from we already studied in AP Physics 1. So number 22, power in terms of F and V. P equals to FV. F is the force and V is the moving velocity of the particle. So we need to know that. Number 23, B field due to a long straight wire. The magnetic field due to a long straight wire is around the straight wire. The formula is mu 0 I over 2 pi r. Mu 0 is the constant and I is the current in the straight wire. And 2 pi r is the radius, I mean the distance to the long straight wire. B field in a solenoid. B field is a magnetic field equals to mu 0 mu and I. Yeah, you see there are two mu's, but mu 0 is the material. I mean, if the solenoid you put put some material inside the solenoid, the mu 0 will be different. And mu is the constant, and n is the number of the loops, and I is the current inside the solenoid. 25. Magnetic flux. The flux is what? Hey, you see, this is really strange because if you don't study calculus, you cannot do the integral, but we just need to know a little bit about that. The flux equals to d times dA, which is, after the integral, the area, on the area, the total points added together equals the flux. 26. Faraday's law. Faraday's law equals to what? I mean, we are going to find the EM. So EM equals to EMF equals to negative n times d phi dt, which is this is sometimes we don't need to know like really deep about this formula, but we still need to know d phi dt. D phi dt is the flux changing in flux, and times the number, and then we'll get the potential, which is the EM. EMF due to the moving bar in a B field. When a bar is moving uniform, like a magnetic field, we are going to use this formula. Yeah, F equals to BLV sine theta. B is the magnetic field, L is the length of the bar, and V is the moving velocity of the bar. And sine theta is the theta is when you move this bar into the magnetic field, the uh, the the angle between B and V. Okay, we finished all the electricity one, so we are step into the fluids. 28. Absolute pressure beneath the surface of an open liquid. P absolute pressure equals to rho gh plus P0. P0 is the basic one. It's just 1.01 times 10 to the fifth Pascal. And rho gh, rho is the density of the water or some beverage, just water of the liquid density. And h is the height. I mean the height to the distance between the point to the open liquid. So added together is the absolute pressure. Definition for mass density of the substance. Just is so easy. Rho equals to m over v, the mass divided by volume. The buoyancy force. The buoyancy force equals to rho f g v. So rho is the liquid density, and g is 10 newton. You know, and v is the volume displaced by water by so items together is the buoyancy force. The equation of the continuity. AV is the volume flow rate. So the volume flow rate is always no change. So if you change the area and then the velocity will change, but the A times V will not change. So this is the formula A1 V1 equals to A2 V2. When you make the area bigger, the V2, or the velocity will be smaller. So it's not a linear, it's an inverse proportional relationship. 32. Bernoulli's equation. This is so long. So sometimes I think last year the AP test, the real question for the free response, we use this to determine like how high this hole in the tube, but we don't really think this is really popular. This formula sometimes we don't need to use it. So, but we need to know about it. P1 plus 1 half rho v squared plus rho g y1 equals to P2 plus 1 half rho v squared plus rho g y2. Okay, let's step into the thermodynamics. 32. Heat flow rate by conduction. When you touch something, which means the conduction happens. When the temperature is different, the heat will flow in from high to low. Q divided by T equals to K A T2 minus T1 over L. Q is the heat, which is the unit is the joules. So heat per second equals to K is the constant, and area is the cross-section area when you touch something. When you use your hand to touch a wall, and the area is the area of your hand. And T2 minus T1 is the difference between two particles, and L is just the length. 35. Linear expansion due to the change in temperature. So if the particle is heated, the temperature increases. the length of the particle will be increased. So delta L equals to L0 times, not times, because it's proportional to the changing in temperature. The volume expansion due to the change in temperature is same as the length. Delta V equals to V0 and proportional to delta T. And this means when the temperature increases, the volume increase. Equation for entropy for an isolated system never decrease. S is the entropy, but it cannot be less than 0, because the reaction cannot reverse. 38. In the ideal gas law, PV equals to nRT and equals to big N KB times T. N is the number of moles, and R is the constant, T is the temperature, and P is pressure, V is volume, N is the number of the molecules, KB is constant, and T is the temperature. 39. Combined ideal gas law. P1 V1 over T1 equals to P2 V2 over T2. It means when P1 increases, if T is keep controlled, P1 increases and V1 will be what? Will be decreasing. And if we control V is constant and P increases and T will be increased as well. So P and V, they are inverse proportional relationship, and P and T or V and T, they are linearly proportional relationship. 40. Heat needed to change the temperature of the substance of mass M with a specific heat C. Q equals to C M and changing in temperature. T2 minus T1 is changing in temperature, and C is the specific heat for different liquid or different particles, and M is the mass, and Q is the heat or work. Heat, number 41. Heat needed to when a substance phase change. For example, when the ice cube is melting, the phase changes. So we are going to use the formula Q equals to M times L. L is the constant but it's different for different things like wood, coal, and ice, and water, and air. So when the phase change, the energy loss or the energy gain, we are going to use this formula Q equals to M times L. M is the mass. 42. Average translational kinetic energy for a molecule. This formula is really important. Kinetic energy equals to 3 over 2 kB times T. K is constant and T is the changing in temperature. 43. Room square speed for a molecule. For the average, we are going to get the average velocity of the moving particle. So we use this formula. V equals to square root of 3 kBT over mu. Do you think you can remember that? But mu is the constant, and K is also a constant, and T is the temperature. 44. First law for thermodynamics. Delta U equals to Q plus W. We need to know heat engine, refrigerator was kind of sometimes release the heat, gaining the heat. You need to use this formula to know sometimes is heat increasing or the work is increasing. 45. Changing internal energy of the monoatomic ideal gas system is kind of similar to the kinetic energy we just talked about it. So, but this time it changes to n times r times delta t and 3 over t 3 over 2. It is the number of the number of the moles of the ideal gas, and r is the constant. 46. Efficiency of a heat engine. So the efficiency we all know, not in physics, but we sometimes use for chemistry and math. We all know the efficiency is, which is good for us, divided by the total work, which means sometimes they will lose some energy, but we only use part of it. So the part of it divided by the total is the efficiency. 47. Efficiency of a Carnot engine. It's just the same, like the number 46. Okay, finally we step into the optics and the waves. Number 49. Definition of the intensity. Intensity equals to the power divided by area. So watts over meter square is the unit of the intensity. Relationship between intensity and the amplitude. Intensity is proportional to the area square, and it's also proportional to the frequency square. 51. Relationship between the intensity and the distance r is the inverse. You see, I and 1 over r squared, because it's 1 over r squared, it means it's inverse proportional to r squared. 52. Speed of wave on the string in terms of Fr and m divided by L. The formula is V equals to square root of Ft over m over L. L is the length of the string, and F is the tension force, m is the mass. 53. Bit frequency. This is for the average version. We actually don't need to really know that, but sometimes when, for example, like let me give you an example. Like when two cars and driving, and each car is holding different beat. The wavelength or frequency. So the frequency of the beats between the two cars, we use this formula. F beat equals to F2 plus F1. It can be positive or negative, but we use the absolute volume to get the magnitude. 54. Snell's law of the refraction. N1 times sine theta equals to N2 times sine theta. This is for the refraction reaction. 55. Index of refraction of a material. N equals to C over V, and A equals to lambda R over lambda N. C is the velocity of the light, and V is the velocity of the particle. And so when you're traveling from the air to water, the lambda of air is different from lambda of the water, and the velocity will be changed. 56. Relationship between the focal length F and the radius R. The focal length, we all know the radius is two focal point length. So F equals to R over 2. Because it's a circle, it's like a diameter and the radius relation. 57. Critical angle for total internal refraction. What is the total internal refraction? It must occur in from from a dense one to a less density one. So it means there's no refraction and everything is total for reflection. So sine theta equals to n2 over n1. The value between n2 over n1 is the theta of the sine value. 58. Past difference of the construction interference for double slits. This is really hard. And double slits is the two holes between on a surface, and we use the formula d sine theta equals to m lambda. Lambda is the wavelength of the light, and d is distance between two slits, and theta is the difference between the two lines, and m is the constant. Sometimes it means the peak. We don't know. The peak can be 0, positive 1, or negative 1, positive 2, or negative 2. 59. Is the distance between m's order maxima to the central maximum for the double slits interference fringes. It is based on let's go back. 58. D sine theta equals to m lambda, and this one we change to m equals to ml lambda over d. Is the distance between is on the film. We need to know the distance between two peaks, and m can be 1, 2, or 3. Constructive interference for thin film. This is there's a question about the film, but it's really hard. There's no need for us to remember or be familiar with that, so no need to remember. But sometimes we need to know a little bit about it. 61. Mirror thin lens and equation. 1 over f equals to 1 over d0 plus 1 over di. I is the image and O is the object to the lens mirror, and f is the focal length of the mirror or the lens. 62. Equation. The magnetification equals to negative di over d0 equals to hi over h0. The last one, the modern physics. 63. Energy of a photon. Energy of the photon equals to h times f and equals to hc over lambda equals to pc. H is the constant, and f is the frequency, and hc over lambda, and the pc. P is the momentum, and c is the velocity of the light. 64. De Broglie wavelength. The wavelength equals to h over p. H is the constant and p is the momentum. We need to know it. 65. Photoelectric effect equation. The maximum kinetic energy equals to hf minus phi. And 66. Einstein mass energy equivalence. The energy equals to mc squared. Changing in energy equals to changing in mass c squared. This is really fun because related to our life, before the test, somebody just review really hard and they will lose a lot of weight. So they use the energy, they put the energy into study and they lose the weight. So this is a relationship between the mass and energy. So it's really fun. 67. Range for hydrogen atom diameter and the nucleus diameter. The proton and the whole particle, the distance between that, the nucleus is really small. The nucleus is really small. It's probably 10 times negative 15 meters, and the hydrogen atom diameter is 10 times negative 10 meters. So the difference between that is 10 to the fifth. So 10 to the fifth is 100,000. Yeah, it's 100,000. So it's kind of like a football in a football in a football field. 68. Heisenberg's uncertainty principle. We don't need to know that, but just we need to observe this in the future. And delta x times delta p is greater than h over 2 pi. And delta E times delta T is greater or equal to h over 2 pi. 69. Nuclear equation for the alpha decay. So alpha decay is focusing on the helium He 4 over 2. Nuclear equation for positive or negative beta decay. Beta decay is just a electron or positron decay. 71. Nuclear equation for gamma decay. Gamma is just release the energy, but there's no there's no mass and no charge. 72. The relativistic factor r equals to 1 over square root 1 minus v squared over c squared, which is greater than 1. So we need to know 73. Length of the construction L equals to L0 over R. But we just say it is R. So R is greater than 0, so the length will be shorter. Time dilation. Delta T equals to delta T0 and times R. So R is greater than what? Greater than 1. So delta T will be greater than 1. So the time will be longer when you're traveling so fast. 75. The relativistic mass. It also times R, so the mass will be bigger. The relativistic momentum. It also times R, right? So the momentum will be bigger. 78. Gauss law or theorem. Changing in electric field times dA equals to Q over lambda 0. This is really hard, but it's not in AP Physics 2. But I know some people taking AP Physics C. This is in AP Physics C. Yeah. And Ampere's law. This is also in AP Physics C. So AP Physics C students, you need to know it and really good at it. After you finish AP Calculus, because there's the integral and derivatives, you need to use it to figure out the problems. So that's it. That's the formulas review for AP Physics 2. The whole thing. If you know all the formulas and remember it, and you don't need to use the reference sheet, because the reference sheet not only there's just a very few formulas, and you don't have time to flip back to the formula sheet and find which formula you're going to use, and just remember it. And just kind of like a review for, and it also is a new thing for the next year or future students who study AP Physics 2. This should be really beneficial and helpful. So hope you like it, and happy physics and happy summer, and thank you for listening. And this is item K, and that's it. So hope you have a nice summer and enjoy it. Thank you.